In this section of Chapter 12, we're going to introduce the concepts of pH and pOH. The acidity of a solution, so how acidic a solution is dependent on the concentration of those hydronium ions. And we can say the same thing for the basicity of a solution. So the basicity of the solution depends on the concentration of the OH minus or the hydroxide ions. Those concentrations can range over quite a large order of magnitude. And so for ease of calculations and for ease of writing, we use the pH scale to describe the acidity of a solution. And we can also use the pOH scale for the basicity, although most chemists just use the pH scale because there is such a thing as determining the basicity of a solution with just a pH scale. How do we define the pH? pH is described as the negative base 10 logarithm of the concentration of the hydronium ion expressed in moles per liter. How does that look mathematically? Well, here it is. So the pH is equal to the minus, that's the negative, logarithm base, so log base 10, and we don't write it, but it's log, not the ln. So minus log of the concentration of the hydronium ions. We can express the pOH in a similar way to the minus log of base 10 of the concentration of the OH minus or the hydroxide ions. So if I know these concentrations, then I can find the pH and the pOH. I also know how to get to the concentration of one and from the other because I know that the product of those two gives me 1 times 10 to the minus 14 at 25 degrees Celsius. We just got done talking about that in the previous video. Let's take a look at how we calculate the pH of a solution when we know the hydronium ion concentration. So determine the pH at 25 degrees where the hydronium ion concentration is 3.5 times 10 to the minus 4 molar. Here's my definition of pH. Minus log of the concentration of H3O+. Now I have the concentration in molarity, which is the correct unit for the pH. So all I have to do is write minus log of this number, 3.5 times 10 to the minus 4. And when I do that in my calculator, I should get 3.46. Make sure that you know how to use your calculator when you're doing these. Every calculator seems to be slightly different. Some want you to hit the log base 10 first and then the number, enter the number. Some want you to enter the number and then add the log. But figure out how to use your calculator. If you have to go back to the manual or go online and watch a YouTube video on how to use the calculator. If you are in my online courses, it would be a little more difficult. If you're face-to-face, I will teach you how to do this in class. But if you're on my online courses and you show up for office hours, I can certainly show you how to use your calculator to calculate pHs on your own calculator, because you will need to know how to use it. Okay, following this example, try B and C and see if you get them correctly. Don't be discouraged if you don't. Try them, don't get them the first time. Just try them a few times and see how that goes. We have to calculate the hydronium ion concentration when the pH is 4.76. For this, we're going to use a slightly different formula. And here's the formula. The concentration of H3O plus is equal to 10 raised to the power of the minus pH value. So this is what we're going to use if we know the pH and we want to figure out the concentration. The other formula, the pH equals minus log of H3O plus, we use that when we know the concentration of H3O plus and we want to figure out the pH. Here we know the pH, we want the concentration, and we use this formula. So then the concentration is equal to 10 raised to the power of negative 4.76. Don't forget that negative sign. If you do that correctly in your calculator, you should get 1.7 times 10 to the minus 5 molar. I will give you some time to try B and C on your own. Now, let's determine the pOH of a solution when the hydroxide ion concentration is 3.7 times 10 to the minus 5 molar. We have the concentration, we want the pOH. For that, we will use this formula. pOH is equal to minus log of the OH minus concentration. pOH is equal to minus log of 3.7 times 10 to the minus 5th. If you do this correctly, you should get pOH equals 4.43. Once again, do B and C just so you can get some practice with figuring out how to do minus log, these types of calculations. And lastly, calculate the hydroxide ion concentration where we know the pOH. The pOH value is 4.91. Similarly to the pH, when we know the pH value, we use the H3O plus concentration is equal to 10 raised to the minus pH power. Here it's very similar. pOH minus concentration is equal to 10 raised to the minus pOH value. Or doing A for you, OH concentration is equal to 10 raised to the minus 4.91, which is the pOH value. That then gives me a value for the OH minus concentration of 1.2 times 10 to the minus 5 molar. Go ahead and try this as well on your own to make sure that you get the same answer, just so that you know how to do the B and C. Okay? Then take some time to work on B and C on your own.